Let's discuss a problem from strength of materials. Okay, so what is given is we have a two rods, steel and axial bars, steel and aluminum, and you have a gap of 0.001, okay, at room temperature. We heat the system uniformly. One thing that is missing on this figure is that the steel is of 0.5 meters length, okay, and there's a gap of 1 mm, which is 0.001 meter. Okay, and the coefficient of thermal expansion of both steel and aluminum is given. So we heat the system uniformly. That means the temperature of the steel and aluminum are same at any point of time, and they expand only horizontally. That is again the assumption. So as they expand, obviously as the temperature increases, the steel will expand as well as the aluminum will expand, and at a point will reach when they both touch each other, and after that the expansion of the individual expansion will be restricted by the other uh, mutual expansion will be restricted by the components, and the stress will develop, but till that point nothing will happen. So that is what is asked: how much temperature delta T I can, delta degree is the temperature rise, so how much delta T I can increase so that I can, the max I can maintain without any stress. So obviously if you assume that the expansion for the steel is delta S plus expansion for the aluminum is delta S, so this is the total expansion, and this has to be less than or equal to this 1 mm. So at the point when they touch, this is just equal, and that is the extreme point beyond which the stress would be start creating. So this is 1 mm, so I just keep everything in meters, so 0.001 meters. Now delta L, the thermal strain is alpha delta T, and the thermal strain is delta L by L alpha delta T for any temperature rise. So delta L is L alpha delta T. So keeping this in mind, the delta L is of steel is delta S, length of the steel delta T, plus delta L of aluminum, length of aluminum. Delta T is uniform, both are heated uniformly, both have the same temperature, so delta T is the common thing. Now alpha S is 12 into 10 power minus 6 meters. This is per Kelvin, into length of the steel is 0.5 meters. Aluminum is 24, twice the expansion of coefficient that of steel, into 0.499. Okay, this is 0.499. Okay, and this is 0.001. So if I multiply this, I get 17.976 into 10 power minus 6 delta T is equal to 0.001, and from this delta T comes out to be 55.629. It's more or less 56 degrees Celsius. So this is the temperature rise that would, this is the max temperature rise which you can provide without touching each other. Okay, this is a simple problem. Okay, just you need to know how to calculate thermal strains. Thank you.